Hey guys, this is Mr. Waite. This will be a quick one today, a quick video, and I'm going to explain to you how to find the perimeter and the area of a rectangle. The reason that we're going to go pretty quick today is because I think these will be pretty easy concepts for you. In fact, many of you or most of you probably already know how to find the perimeter and area of a shape like this. So we'll just go over it real quickly. Let's say we have a rectangle, this beautiful blue rectangle that I drew freehand. And we'll say that this rectangle has a length of 3 meters. I'm going to use my abbreviation M for meters, and a width of 5 meters. Okay. Usually when you have a problem like this, it's asking you to solve for a perimeter area. They won't give you more information than this because we'll just use our knowledge of rectangles to realize that, well, if I know that one width is 5 meters, then of course, since rectangles, the opposite sides are equal, we know that the bottom is also 5 meters. Same with the lengths on the left and the right. These two sides are both going to be 3 meters. And now we have all the information we should need to find the perimeter, which is what I'm going to do first. The perimeter, and some people like to remember this by looking at the word rim inside perimeter. You can think of a basketball rim as being like a circle that goes around the net where the ball goes, or the rim of something is usually the outside or the distance around the outside of something. And mathematical perimeter is the same thing. It's just a measure of the distance around the outside of a shape. Or in this circumstance, it's just the sum of all the sides. Okay, you can do this a couple different ways. You can just start at a place and measure the sides as you go around. 5 plus 3 plus 5 plus 3. Okay, this is a pretty easy one, so I think right away you guys would realize that, I got my eraser on, you guys would realize that 5, so P is equal to 5 plus 3 plus 5 plus 3. Pretty easy math problem right there. That's going to give us a total of 16 meters. There's also some formulaic ways you can think about this. You could think to yourself, well, perimeter is going to equal, if it was something like a square, you could say it's 4 times the length of the side. However, in this case, we're not dealing with a square, so the sides are different. So we have to think of it a little bit differently. Since it's a rectangle, we could say the perimeter is equal to 2 times the width plus 2 times the length. That's a little algebra right there for you guys. Remember, these two right here, these two numbers are just variables. They can change. So like in this situation with this rectangle, the width we said was 3 meters and the length was 5 meters. So all you would have to say is that the perimeter is equal to 2 times, we said the width was 5, 2 W's plus 2 times the length is 3. Okay, so that would mean that P is equal to, well, 2 times 5 we know of course is 10, and 2 lengths, 3. 2 times 3 would be 6. So that would give us a total perimeter of 16 meters, which is the same thing that you would get if you just added all those up. Okay, pretty simple. It is important that you guys kind of think about what we did right here. I know this is a more complicated way of thinking about it, but these formulas are going to be important to you guys, especially as you start to move into like middle school math. Okay, if you can think about how to represent that perimeter as a algebraic formula like that, that'll be very good for you guys. Okay, area. Let's talk about area real quick. Let me just erase this stuff. Remember, you can always pause this video at any point if you if I'm going too fast, or if you just need to think about it for a minute, okay? So I erased part of the word of area. Let's make that a little smaller. Okay, so now I've got my rectangle, and I'm going to leave my length and width the same, and I'm going to find the area, okay? Just like we said, perimeter is the distance around the outside of a shape. Area has a different mathematical definition, which I'm sure many of you know already. The area is the space inside of a shape. Okay, in other words, how much two-dimensional space does this rectangle take up would be our area. Okay, and since it's a two-dimensional shape, we're going to represent this area in square units, which this may start to look really familiar to you guys, so pay attention. So if I think about it like this, if this shape, this rectangle is 3 meters long, okay, I could divide that up like this. In other words, I've got 1, 2, 3 rows, or 3 meters long, and if it's 5 meters wide, that could look something like this. My drawing's not perfect. Okay, so the area of this shape, or how much space, how much two-dimensional space this rectangle takes up, is just going to be the sum of all these square units inside, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That one didn't mark. There we go. Okay, so my area in this case would be 15 meters. Since they're square units, though, we're going to say meters squared. Remember, you can write meters squared like this, or you can write it like 15 square meters. Okay, that's going to be our solution right there. And hopefully by now you are already realizing that this is just like when we use an array to represent a multiplication problem, right? These two are basically the same concept. Okay, and just like with arrays, when you want to calculate the area of something, we don't have to count these individual square units inside. We can just use our knowledge of multiplication to solve for this, right? We know if we have 3 rows with 5 in each row, or 3 rows of 5 or 5 rows of 3, it's a rectangle. We know we can solve that mathematically by just doing the area is equal to 5 times 3. Obviously, that's going to be super easy. It's a math fact. 15 meters again. We'll make sure that we square our units right there because we are talking about an area or two-dimensional space. Okay, pretty easy. Yeah, the only other thing I would say to you guys is that, remember, just like with arrays, we can draw our square units on the inside of this shape pretty easily because there was only, 3 and 5. So I was able to pretty easily trace this. But if you got into a bigger shape, then you wouldn't be able to draw the square units, but you definitely shouldn't have to, right? Because you can just find the area using multiplication. Just like we said that you could represent perimeter as a formula, you can do the same thing with area. Okay, just like perimeter was the sum of all the sides, like 2 lengths plus 2 widths. Area of a rectangle is just going to be the length, that's our fancy L to represent length, times width. And that's it. So in this case, 5 times 3. I kind of switched those around because 5 was our width and 3 was our length, but you get the idea. So if I had let's say our rectangle here was a much bigger rectangle, there's no way I would want to label all the individual units inside of it. So if I had something like, you know what, let's switch it around a little bit. So if I had something like this, oops, oh, I messed that up. Probably hear me sliding this iPad on my table. Again, I haven't worked out all the kinks of recording this, but for now it'll have to do. So let's say that I have a rectangle like this and it's got a much bigger, like its dimensions are much bigger. Maybe I have something like 100, let's use something with different besides meters. Maybe we could do, go to customary and do miles. So 100 miles wide and 275 miles long. There's no way that I want to draw 100 different columns inside there and 275 different rows inside there. That would take forever and it would look ridiculous. Fortunately, I know that since this area is a rectangle, I can just use my formula, length times width. Okay. And I know that the area is going to be equal to, in other words, how many tiny little square units, or they're not tiny, they're miles, how many square miles would be inside that shape. So we're obviously looking at a very big rectangle, but it would be equal to 275 miles times 100 miles. Okay. When this is actually a mental math problem, to solve it's pretty easy. So remember that if you have you guys see the math fact in here? Basically, the easy mental math problem in here would be that 275 times 100 is like doing 275. Oops. Let's try that again. 275 times 1, right? Which would give me 275. And then I could add the so 275 times 1 is 275, and I would have to cover up those two zeros to find that. So of course I would have to add them back on. So my final area would be 27,500 square miles. I'm gonna write my unit down here because I kind of ran out of room. Okay, so that would be my final solution right here. Okay, I hope that's making some sense to you guys. Again, this was sort of, it ended up not being that quick, but I think it's covering concepts you already knew. Hopefully maybe I threw in a few things that were new for you, like how to show those measurements, area and perimeter, with a formula. And besides that, though, I think this should have looked pretty familiar to you guys. Now, later in the week, we will do some assignments. We'll probably do some challenge activities with perimeter and area, even though they will use your knowledge of finding the perimeter and area of rectangles. We'll set them up in a more challenging way that will still hopefully kind of enrich, or I guess kind of make you push your brains a little bit with this, with these concepts. Okay, I hope that was clear. As always, you can email me or write me a message in Google Classroom or whatever if you're having a question or concern about this concept, and be on the lookout for the assignment that goes with this stuff. Okay, have a great day.